Hey, welcome back, students. In this video, I'm going to go ahead and show you how to identify the limiting reactant. So we do have a balanced equation right here. We have 1 mole of carbon monoxide reacting with 2 moles of hydrogen gas, going to form 1 mole of CH3OH. Okay, so we have the problem here. The question reads as follows. Based on the balanced reaction below, what would be the limiting reactant if 34.6 grams of CH3OH reacted with 88.1 grams of hydrogen? And so what we've got to do first is set up our table. Now, I've already got the table drawn here for you. All you need to do is kind of fill it in, and so let me go ahead and start doing that for you. One of the first things that we need to do, though, is go ahead and make our dividers, and so let me divide them for you. Every time we see an arrow, we're going to write a line down. Every time we see a plus sign, we'll put a line down. Essentially creating columns for each of the compounds at the top, and so each of the compounds at the top forms the column heading, telling us that this particular column belongs to that particular compound. And so if we look at this problem here, we start off with grams and grams. And so essentially, if I do that, let me identify those parts here. We know that we begin with 34.6 grams of CH3OH, and we also begin with 88.1 grams of H2. So all I'm going to do is kind of enter this information into the table in the row for grams. And so I'll begin with the 34.6, and let me enter that here. So we'll put 34.6 grams of CH3OH, and we're going to put 88.1 grams of H2. Let me make that a little bit better just so it's better to look at. And so there you go, 88.1 grams of H2. The next thing for us is to identify the molar mass. If I look at the mass of each hydrogen, since there's 2 of them, it's going to be 1 times 2. So the molar mass of hydrogen here is 2 grams per 1 mole of hydrogen. If I look at the molar mass of CH3OH and add the mass of carbon and 4 hydrogens and 1 oxygen, the mass that I come up with here is 32.01 grams per 1 mole. Okay, next thing I need to do is kind of find the moles. In order for me to find the moles here, I need to divide the grams by the molar mass, and since the table's already set up this way, all I really need to do is divide going down. Okay, and so that's the movement that we've got. We're moving downwards. And so if we move down, we're going to divide. If I were going up and trying to find grams, obviously I would do the opposite and multiply. But in this case, since I'm moving in a downward direction, I'm going to divide these two numbers. So I'm going to take 88.1 divided by 2 to give us 44.05 moles of H2. And if I take the 34.6 divided by 32.01, what I wind up getting here is 0.0108. And this is moles of the CH3OH. Okay. All that's left to do now is to come in here and identify the moles that I need. And so let me put that here. This is the moles that you need here at the bottom. And so all I'm really trying to do here is solve for essentially what would be the X and the Y. Okay. And so the way we do that here is we're going to take the first number here. We're going to take the following. So I'm going to take this 0.01808 and I'm going to multiply that times the 2 divided by 1, and that'll give me the answer here that I want. And if I go ahead and do that math there, what I wind up getting here is 0.0216 moles. And that's how much I really need of the H2 if I start with 0.0108 moles of the CH3OH. Now I'll go ahead and do the same thing but in the reverse order. So this time I will go ahead and begin with the other one. So let me go ahead and pause here and kind of erase this and see if we can come up with that. Okay, so essentially what I'll do here is I'm going to start with the 44.05. I'm going to go ahead and multiply that times 1 divided by 2, and that'll give me the Y that I'm looking for. If I do that math there, what I wind up getting is the following: 22.03 moles of this particular compound, CH3OH. All that's left to do now is to go ahead and subtract. So I'm going to go ahead and take this number here, 44.05, and I'm going to subtract the 0.0216. If we do that, what you're going to wind up noticing is that we're going to have a lot of excess. Plenty of this hydrogen gas left over. If I go ahead and do the same thing to the other side and take 0.0108 and I subtract the 22, it's pretty evident here that if I subtract this, I get a negative number. And essentially what this means is that I do not have enough. Okay? If I don't have enough, this compound here, CH3OH, this one here is the limiting reactant. And so it's the one that's going to limit us in the overall reaction, because once this one is used, the reaction stops. Okay, so that's the way you identify the limiting reactant.